So we want to discuss the slope-point form of linear equations. We've talked about the slope-intercept form. Sometimes you'll hear this method actually called the point-slope form as opposed to the slope-point form. So if you hear either of those, they're both the same idea. And the idea really is that the slope-intercept form, which we talked about in the previous video, requires that you have the y-intercept. So it requires a particular point. This method, or this form, requires only that you have a point on the line. All right? So it's y minus y1 equals m onto x minus x1, where m is still the slope, but x1, y1 is just any point that's on the line. Okay? So you remember probably this formula, hopefully you do, that m is y2 minus y1 over x2 minus x1, and really all the point slope formula or slope point formula is a rearrangement of this. If you multiply this, you get y2 minus y1 is equal to m onto x2 minus x1. And then all we do is replace y2 with the point xy, so you get this. So really all we're doing in terms of a derivation, if you're interested in that, and you may not be, and that's okay, but you may be, is just rearranging the slope formula. That's what we're doing in order to get this form, okay? So if we want to describe something that's in that form, this tells me the point and the slope, these three pieces of information. But you have to be careful, because if you look back here for a second, it's y minus y1. So whatever this sign is goes with y1. But this is in brackets. It's x minus x1. All right. So if you have a plus, like we do here, and same thing here, if we have a plus, then actually the y value or the x value, x1 or y1, whichever you're talking about, is the opposite sign. Okay. So in other words, if there's a negative here, the y1 is positive. If there's a positive here, the x1 is negative. So what we can do is say the slope of that graph is 1/3, and it passes through the point -4 and -2. Sorry, and +2, not -2. So we switch these signs, all right? And then it says to graph the equation. So all I'm going to do is I'm going to go to this point, -4 and 2. So that's 1, 2, 3, 4. There's -4. And then 1, 2. There's 2. Okay. So I'm going to plot the point. And I know this is fairly small. This grid is pretty small, but we can deal with that, I think. And then what we're going to do is we're going to use the slope, just like we did with the slope-intercept form. So we're going to rise and run whatever the slope is. The slope is 1/3. So I'm going to run 3. So that means 1, 2, 3. I'm going to run 3, and then I'm going to rise 1. So I'm going to be here. And then I'm going to draw a line through those 2 points. So I'm going to draw a line through those 2 guys, and that's my graph. So it's very similar in terms of graphing to the slope-intercept form. All we're doing is we're graphing, instead of the intercept, we're just graphing whatever point is that we have, whatever point that we're given in that equation, right? So we need 1 point and one, well, actually, I guess we need the slope and 1 point. So it doesn't have to be the intercept, but we need the slope. So if we can get the slope from a graph, great. If we can't, we need 2 points to find the slope. And then we can use one of those points in our equation. So let's look at another example. All right, describe this graph. So we know, first of all, that the slope of this graph is -1/2. Okay, that's coming from here. And then it goes through, or it passes through the point -2 in here. So we switch that sign and make it 2. And this is +1, so we switch it and make it -1. So it becomes 2 and -1. So we're going to go to the point 2 and -1. So 1, 2, and -1 is right here. Assuming that this grid is going up by 1 in the scale. All right, so we'll go, there's 1, 2, and then -1. And then our slope is -1/2. So that means if I run 2, I go down 1. So there's my next point. Okay, so my 2 points are here and here. Again, the grid is small, but that's okay. We can work with that. But you need to then draw a line through those 2 points, and it needs to be as straight as possible. So if you have a ruler, that's excellent. You should use that. If you don't have a ruler, then I would strongly suggest that you invest in one for these questions because it will make it much better. And then we have to put arrows on the end of our line to make sure that it indicates that we continue forever. So there's my graph. So very similar to slope-intercept form. It's just that we start at whatever point we're given as opposed to starting at the y-intercept. Okay. Now, in order to fill in this equation, we just need a point and the slope. That's all we need. Okay. So once we fill it in, then we can rearrange it to any other form. So you notice this says write the equation. What's the equation of the line that has a slope of -2? So we're going to write m is -2. And then it passes through -4 and 12. So that gives me x1 and y1. So we're going to write that first as y minus y1. So y minus 12 is equal to m, which is -2, onto x minus -4. So x plus 4, right? In other words, we switch these signs and we put them into the equation and leave the slope alone. Now that's the point slope formula or slope point formula. But we want, you notice it says slope-intercept form. So you remember slope-intercept form is just y equals mx plus b. So how do we switch it? Well, all we do is we go like this. We leave the -12 here for a second and we expand this bracket. So we get -2x and then -8. And then all we do is add 12 to both sides of this equation to get rid of that 12 and get y by itself. So we get y is equal to 2x plus 4, okay, -8 plus 12. So there's my slope-intercept form. So from point-slope form, which is this, or slope-point form, okay, depending on how you want to say it, you can get to the slope-intercept form just by expanding and solving for y. Okay, so here's another example. It says write an equation in slope-point form. So all we need to do is identify the slope and identify a point. You'll notice there's 2 points that are already identified for us. This point is -1 and -2. So I'm going to use that as my point, and then I need the slope. So I'm going to go up to this point. So that means I'm going to run 1, 2, 3, 4 and rise 1, 2, 3. So my slope, which is my rise over my run, we said is 3 over 4, okay, because we ran 4 and rose 3. And my point is -1 and -2. So I'm going to switch those signs. So again, so it's going to be y plus 2 is equal to 3/4 onto x plus 1. All right, there's my point slope form or slope point form of my equation. Then the question says, write that in slope-intercept form. Okay, so to do that, all I do is I take that and I expand the bracket first. So I go y plus 2 is equal to 3/4 x plus 3/4. Okay. And then I subtract 2 from both sides. So I subtract 2 from here and subtract 2 from here. And this is where it gets interesting, I guess, because we have to take 3/4 and subtract 2. Okay, now 2, if we write it as a fraction over 4, is 8 over 4. So we can go 3/4 of x plus 3/4 minus 8/4. Okay, and then 3/4 minus 8/4 is minus 5/4. So I go, that's actually 3/4 of x minus 5/4. And that's my slope-intercept form. So then it says, what's the y-intercept? Well, the y-intercept, based on that slope-intercept form, then is 0 and minus 5/4. Okay, because we get it from right there. And you can look on your graph to make sure that that makes sense. So if I go here, look, there's -1 and then another little bit. So minus 5/4 is minus 1.25. So that makes sense. That matches what my graph is saying. So that's how you kind of flip between the two, between the slope-intercept and point slope or slope point form. Okay, so again, same thing, just a different example. So I'm gonna use this point here. You can use any of these points. It really doesn't matter. But I'm just going to use the first one that I see. So it's -2 and 2. And then my slope, I'm going to rise -1 when I run 1, 2, 3. So my slope here is -1/3. And the point that I'm using is minus 2 and 2. So to write it in slope point form, we're going to go y minus 2 is equal to minus 1/2, sorry, minus 1/3, not 1/2, onto x plus 2. Okay, because again, I'm switching these signs when I put them into the equation. And then it wants it in slope-intercept form. So I'm going to just go y minus 2 is equal to minus 1/3 x minus 2/3. And then I'm going to add 2. So that means y is minus 1/3 x minus 2/3 plus 2, but 2 is going to be 6/3. Okay, so that means I have minus 1/3 x plus 4/3. Okay, that's my equation. And so my y-intercept then is 0 and 4/3. And again, you should check your answer to make sure that it matches what is on your graph. So your y-intercept, we're saying it's 0 and 4/3. So we should be able to go here and say that's 1. 4/3 is 1 1/3. Yes, that does match. All right, so that's how you use the slope point form, and that's how you work with changing it to the slope-intercept form. That's how you sort of work your way from one to the other. So we're going to work on some questions from page 372. These are the questions, so I'll show them to you. You can pause the video and work through them if you wish to, but those are the questions that you're going to work on. Now, what we want to do is say, okay, how do I do this point slope form from 2 points? So instead of being given a point and given the slope, how do I do it from 2 points? So what we do, we already know how to find the slope using 2 points, y2 minus y1 over x2 minus x1. So we use those points to find the slope. We take the 2 points that we're given and find the slope. Once we've done that, we take one of the 2 points that we have and use that as the point in the slope point formula. So we find the slope using both points, and then we pick one of them, and that allows us to write it in slope point form. And then if it wants in a different form, we can rearrange. So these are the steps we're going to follow to solve for an equation using 2 points. Okay, and we're going to just do some examples of that, and then again, you can practice more on your own. So here we go. Once you have, I'm just going to erase this, sorry I didn't see it down there. But once you have the steps, we're just going to follow those steps. So here's the question. It says, what's the equation of the line that passes through these 2 points? In point slope form, and then in slope intercept form. So what we're going to do, we're going to call this x1 and y1, and this x2 and y2. And we're going to find the slope first. So the slope is y2, which is 2, minus y1, which is 8, divided by x2, which is 2, minus x1, which is minus 4. Okay, so 2 minus 8 is minus 6, and 2 minus minus 4 is 6. This is 2 plus 4, so we end up with a slope of minus 1. And then what we're going to do is we're going to pick one of the 2 points. I'm always just going to use the one that I've labeled x1 and y1. So I'm going to go y minus y1, which is 8, is equal to the slope minus 1 onto x, and then minus x1, so minus minus 4, so plus 4. We talked about switching the sign, right? So that's my point slope form. I'm done part A. Now part B says, okay, now write it in the slope-intercept form. So part B, all we're going to do is rearrange this. So we're going to go y minus 8 is equal to, we're going to multiply by minus 1, so minus x minus 4. And then we're just going to add 8 to both sides. So if we do that, we get y is equal to minus x plus 4. And that is our equation. So that's the idea. You find the slope first, find one of the points and put it in, get the equation, and then once you've done that, you get your slope-intercept form. Okay, same idea here. So let's just do another example. It really, I just want to emphasize though, it doesn't matter which of the 2 points you use. I just always tend to use the one that I've already labeled x1 and y1, but you could use either one of them. Okay, so let's find the slope first. We need to do that first. So we go y2, which is 1, minus y1, which is minus 2, divided by x2, which is 3, minus x1, which is minus 1. So 1 minus minus 2, that's 1 plus 2, so 3. And 3 minus minus 1 is 3 plus 1, so it's 4. So my slope is 3/4. Then I go y minus y1, so I switch that sign, get y plus 2 is equal to the slope, which is 3/4 onto x minus x1. So again, I change that sign. So there is my point slope formula. Okay. And then I'm just going to say, just to show you this, what happens if I use this one? So the other option is to go y minus 1 is equal to 3/4 onto x minus 3. That is also okay. That is also an equation that works. And I just want to show you that because it doesn't matter, and I just want to show you we end up with the same slope-intercept form. So what we're going to do now is, this is part A, but part B says write it in slope-intercept form. So let's do that. So we're going to expand first. We're going to go 3/4 of x plus 3/4. And then we're going to subtract 2 from both sides. So if I do that, then I end up with y is equal to 3/4 of x plus 3/4, and then minus 8/4, because 2 is 8/4. So that gives me y is equal to 3/4 of x minus 5/4. That's my answer. Now, just want to show you, if we do it over here, we have y minus 1 is equal to 3/4 of x minus 9/4. Okay, 3/4 times 3. And then we're just going to add 1 to both sides. So that gives me y is equal to 3/4 of x minus 9/4 plus 1, which is 4/4. So that gives me y is equal to 3/4 of x minus 5/4. Okay, so they actually give you the same slope-intercept form regardless of the fact that you've used a different point in the point-slope form. So here's another question. This one talks about writing point-slope forms, but they're parallel or perpendicular. So this goes back to the fact that parallel lines have equal slopes and perpendicular slopes are negative reciprocals. So when it says write an equation that passes through this, okay, that's my point that it's going through, and it's parallel to this. So we need to figure out the slope of this line. This is in slope-intercept form, which means we have mx plus b. So the m is 2/3. Because it's parallel, it stays like that, all right? And so my slope is 2/3. My point is minus 1 and 1, so my equation becomes this. All right, y, we switched the y value, right? So it was minus 1, so it becomes plus 1. The slope came from here, okay? And then the x value goes in here, and again, we change sign. Now, what happens if it says perpendicular to the line? So all we do is the slope then becomes, instead of 2/3, we flip it over. We take the negative reciprocals, we flip it over and change the sign. So it's minus 3/2. That's the only thing that changes. So the y plus 1 is the same. We just change the slope, and it's still x minus 1. So if it's perpendicular, you take the negative reciprocal. If it's parallel, you take just whatever the slope is, because they're equal. All right. So here's another example. This one says you've got this point now. So this is our x1 and y1, right? And now it says parallel to this line. So the slope here is 3. Okay, the number in front of the x. So that means my point slope formula becomes y plus 3, right? We take y1 and subtract it, equals 3 onto x minus 2, okay, because we're subtracting x1. And again, the slope is coming from here. So hopefully that makes sense. We're always using this. That's our point slope formula of our line, or our slope point formula. So that's what we're doing. And then it says perpendicular. So if it's perpendicular, all that changes is our perpendicular slope is you flip the slope over. So it was 3, so I flip it over, make it 1/3, and then I change the sign. And then the rest of it is the same. So it's minus 1/3 now, but the rest of the equation stays as is. Okay, so the questions that I want you to try are these. And again, they are included in the rest of there, so you can try these questions, and you can just pause the video and look at those. And then here are some extra questions, and again, you can just pause the video and work through those as you have time, and then the answers are all right here. So you can work through them, pause the video, and come back and check your solution.